Hello, everyone. I'm Well Pragnell, VP of Research and Science, the American Diabetes Association. And today we're joined by two remarkable individuals who have a unique connection through the amazing power of research. We have Dr. Kathleen Page, Katie Page, who is a physician specializing in diabetes and childhood obesity at University of Southern California. She's co-chief of the Division of Endocrinology and Diabetes and director of the University of Southern California Diabetes and Obesity Research Institute. And we also have with us Charis Alexander, who is a graduating student. She's receiving her degree in neuroscience and going on to a MD PhD program at the University of California. Welcome. It's so nice to have you to talk to you. Why don't we jump right in and just kind of, first of all, maybe Katie, can you tell us a bit about your research, and then we can talk about how the connection with Charis as well.
Sure, I'd love to tell you a little bit about it. First, I just want to say thank you to the ADA and the ADA Pathway Program. The ADA Pathway project that I've been working on over the last decade has really been instrumental in providing the resources that we needed to really start these studies, which we've been conducting for the last decade. But it's also really led to an impact on the trainees in my lab who have taken this in new directions in the field. And as you'll hear about today, it's also been enabled people who have participated in our studies to be inspired. So it's been really exciting to hear and learn about this story of the inspiration that a study participant in the Brainchild study had and led to an impact on her decision to pursue medicine and research as a career. So that's been really, really exciting and for me.
Fantastic. And so this was quite some time back, right? So you were doing this research study on the offspring of families who had gestational diabetes, and so you had many following many children. And I understand that Charis was also a part of that group. And so, Charis, you were in this environment of a clinical trial, experiencing all the various activities around that, and that brought you to this day, in a sense. So, for example, all your experiences, and so tell us a bit about what you were doing in the trial, and what was your experience there, and how it may have led to this, to where you are now.
Yeah, exactly. So I started. First of all, thank you again for having me here today. When I was about 8 years old, my parents and I were contacted about being a part of Dr. Page's study. And so we agreed, and we drove down to her lab at USC. And as I got started, just the intention was just, go in and give them whatever data they needed, I suppose. But they were so welcoming, and I noticed they took such almost an educational perspective with it, and explaining to me and my family what the purpose of the study was and what we were contributing to, and also what these tools were, explaining the MRI machine and that process. That was really my first exposure to neuroscience, and it definitely lit a spark in me that grew over multiple years after that, and the follow-ups we would do every couple of years, just being able to see the incredible work that they could do with the brain, and looking at the findings that were coming out from this study. So over time, that my desire to know more about the brain grew, my desire to get into this field grew, and I ended up being able to come back, and because I was first exposed to this neuroscience environment at USC. USC was my first choice to come back and study neuroscience, and it's continued to be my first choice for medical school as well.
Fantastic. And USC has such a strong neuroscience program as well, and it's amazing to be a part of that from very early on, seeing all the activities, seeing actual research happen, and seeing all the various activities as brain scanning and so on. Quite exciting, and must have been a wonderful experience. Katie, tell us a bit about the study and how long it's been going on for, and what are you finding on the study?
Yeah, so this is a study that started back in 2014. So I was one of the first recipients of the ADA Pathway Award. And initially, we were really interested in understanding how diabetes exposure before birth, so when a baby is developing in a mother's womb, how does that exposure increase risk for the development of diabetes later in life? And we knew from some animal studies that had shown really profound results showing that this exposure to diabetes in utero caused changes in the development of brain pathways that are important in regulating appetite and metabolism. And those changes in the brain led these animals to develop obesity and diabetes later in life. So this was the first time that this question had ever been addressed in humans. And so that's what we call the brainchild study. So originally, it was a study that was done in children between the ages of 7 and 10 years old. And one of our first study participants is joining us today. And what we found initially was that the children who were exposed to moms who had diabetes during pregnancy, particularly if the moms had diabetes earlier in the pregnancy, those children had changes in the hypothalamus, the area in the brain that's important for regulating appetite and metabolism. And over the next year, those changes in the brain were related to increases in food intake and increases in weight gain over time. And so subsequently, we've received additional funding from the NIH to carry these studies forward. So over the last decade, we've been doing longitudinal follow-up of these children. And what we found is that we're looking at the data now, but we're looking to see whether these changes that occurred early in life as a result of being exposed to the diabetes environment in utero might lead to changes in risk for developing diabetes as these children go through puberty and into adolescence.
But I understand that lifestyle after birth and just kind of children's activity levels and so on can negate a lot of that negative aspects of gestational diabetes, right? So you can have excellent outcomes. Is that correct?
Yeah, absolutely. So what's really unique about the Brainchild study is that we're collecting very detailed information about lifestyle behaviors. We have wrist accelerometers that the children are wearing every year so that we can understand how things like sleep patterns and physical activity, sedentary behavior, patterns of activity over time, as well as collecting very detailed information about diet, how those factors, those lifestyle behaviors may actually mitigate these risks, particularly as these children go through these really important changes over the pubertal to adolescent period.
Nice, nice. So, Charis, going through this experience, getting in the lab all the time, that's quite amazing. So you've just completed a undergraduate degree in neuroscience. So what inspired you to go and do neuroscience? Because you saw the lab, you saw the research and so on, and you could go into different areas. There's so many areas of research. What inspired you to go into neuroscience? I'm a neuroscience PhD myself, so I absolutely love it, so I can fully understand. But what inspired you?
Yes, I had always kind of wondered, and through the years as I got older and older, the questions about, why are these things this way, and particularly why do people do things, why do people make certain decisions, was always really interesting to me. But I didn't know any field of science that addressed that really at this level, and seeing this study in particular and other studies coming out of similar labs showed me that the brain was really a key to unlock all that information about how people make these decisions, how they process the information, and how you can have two different people presented with the same options, but different choices are made because of those pathways and processes that happen in the brain. So that was really, it seemed like, key and lock fit of something that could unlock all of the answers to all of the questions that I had already had as a kid. I just wanted to mention, I still in the Brainchild study. So when you were mentioning, I actually just went for a follow-up visit this past weekend. So when you were mentioning risk accelerometers, I have mine right here for the next week. So perfect day to do the interview. I can show it's true.
This also discovers how important it is to participate in clinical trials. Clinical studies are so important, for benefit. I mean, these are obviously an amazing benefit here as well in terms of your growth and academic path as well. So, but Katie, I know that there's been so many advances in the last years in terms of the technology, that allows people to kind of understand more about brain function. So, you want to talk a bit about that?
Yeah, I mean, I think that was really this was really one of the first studies, we started it again like about a decade ago, that really was able to utilize some of these new technologies and advancements in brain imaging. So we're using, it's one of the first studies in the field to use what's called functional magnetic resonance imaging, or fMRI, to look at brain changes that occur when people consume glucose. So sort of doing a glucose tolerance test and seeing how is the brain responding, just like we would see how is the pancreas responding. So we can look at how the brain is responding to different stimulants. We can see the brain pathways, so the connections between brain regions. We can look at brain morphometry and see how it's developing and how these pathways are maybe developing different by different exposures, like being exposed to diabetes in utero. So I think the developments in technologies, particularly in brain imaging, and the technologies for using real world wearable devices like the accelerometers, have allowed us to kind of integrate that information in a really new and exciting way.
That's great. So, Charis, when you go and do you're going to do your MD PhD, and I understand you have interest in neuroscience, so you'll be using all these new technologies then in terms of as moving forward, and kind of having all the advantage of all this expertise at USC, all the technology, and also this profound interest in neuroscience.
Exactly. And I think, the more I grow in more education, the more I'm able to, understand more and more about these processes. And I guess, but the amazement doesn't really wear off. So I do plan to hopefully use some of the same tools, and still coming at neuroscience and understanding behavior and decision making as I continue in my next program.
Nice. I know that when you go for your PhD, they encourage you to do rotations under multiple mentors and so on. But do you have a kind of a sense where you'd like to be? What's your kind of major interest in neuroscience?
It's so open. I still, there are just so many fields, subfields of, looking at different perspectives and behavior. So I'm hoping to get as much exposure to different types of things as possible.
That's probably the best, because I mean, one thing you find is that as in your research, and you go through your degree, you get exposed to so many different people and so much expertise in the field. So that's really quite amazing. So you said you're still in the study. You're still in the brainchild studies. So do you go? How do you go back each year, or what kind of measurements do they take?
Yeah, I believe it's once every 2 years, or different things in different years. Remembering, I mean, Dr. Page can tell you more specifically what the protocol is, but I know I've gone back for follow-ups, and sometimes it's blood draws, sometimes it's physical activity and eating, data just about habits and patterns for the past couple of days. We also, wearing the accelerometers for about a week. And then sometimes also for those brain scans, follow-ups, and seeing different images and how the brain responds to food and things like that.
Yeah. And Charis, I understand you actually worked in the lab too a bit, right? So when you were in your undergraduate years, right? Or is that wrong? I was
In this
you did some work there as well.
Not work in Dr. Page's lab, but in through Keck and through USC, then yes, I've been involved in the Infant Neuromotor Control Lab, which is actually another developmental lab connected to USC, and connected to the Children's Hospital of Los Angeles. We've been looking at how, especially infants, and now branching out a little bit even into fetuses before birth, and how they learn to move, what role the brain and the nervous system plays in motor development and learning motor skills. And so we've been able to see a lot of interesting things there as well, and hopefully help with things like neurodevelopmental disorders like autism that might cause movement delays, and then how we can help ameliorate that.
Very nice. Very nice. So again, you're doing your rotations even before you do your PhD. That's excellent. So, Katie, then explain to me then. So, I know that the study actually showed a bit like things around appetite and so on. And can you tell a bit more about that and what some of the findings?
Yeah, so we've had several findings that are, I think, important to the field. One is that there are changes in the development of the hypothalamus, the area in the brain that's important in regulating appetite. And those changes led to increases in weight gain over time. So that suggests, or is in line with the studies in animal models, suggesting that this exposure to fetuses to the diabetic environment might change the wiring of the hypothalamus in areas in the brain that make these children more susceptible to weight gain and potentially obesity and diabetes later in life. So that's one finding. We've also looked beyond the hypothalamus to other areas and circuits in the brain that are important in the motivation to eat. So we've also showed that children who were exposed to diabetes in utero had changes in brain reward pathways, and those changes were related to increases in food intake. So again, consistent with the idea that there may be something about this exposure to diabetes while you're developing, even before birth, that wires the brain in a way that may make you more susceptible to eating and cravings for food, as well as increases in weight gain over time. Lately, more recently, we've been really trying to understand, are there ways that you could mitigate these risks that you were exposed to early in life? And so we have preliminary findings suggesting that increases in better sleep, as well as increases in physical activity during childhood, may mitigate those risks for developing obesity and diabetes.
So what if say a parent is watching this, what advice, what guidance would you give to them, or what should they prioritize for their children?
Yeah, I think that it really goes to all of the things that are recommended already, but I think really kind of emphasizes the message that it's important early in childhood and through development. This is a really sensitive time, not only for the brain developing, but also for the development of other tissues. So it's important to make sure that our kids are getting enough physical activity and eating healthy diets and getting enough sleep. And I think these are things that sound simple, but they're actually much more complicated in the world that we live in today. But I think you can see that from our findings, as well as other studies, that these are really important ways that we can help prevent disease and get our children on trajectories of better health from an earlier stage of life.
Great. And Charis, you're a trailblazer. I mean, you're doing your degree in neuroscience, going for MD, PhD, really just a leader. What advice do you have for people your age, just now graduating from school? And so how do you do that? What advice do you have to go down the scientific path for people?
I would just say probably be patient, and I mean, I know I have to tell myself this is looking at 7 to 8 more years of school, but just that willingness to be patient in lots of different environments, whether it's coming into a lab setting where you realize there's so many things that you don't know, so many things that you don't understand, but having that humility and willingness to learn, and you'll never run out of things that you can learn, and people willing to teach you if you take that perspective, and also just to go after and take some initiative even in your own learning to find these things. I mean, this one I had that first exposure, but I also had a lot of other people around me who encouraged me to push forward and to pursue the degree in neuroscience and not let those ideas, I guess, stay in my head as just fun curiosities, but to actually go after and pursue them and turn them into something that turned into, thankfully, being able to major in neuroscience and continue in it now.
Yeah. So, I mean, there's a huge advantage of being part of a study, be ready to kind of experience that. But what you're saying is you can, people should go and explore there's so many opportunities out there for young, bright researchers, young, bright people for education to move forward and to follow the path of their dreams in terms of how they want to get educated and their what potentially research in life. And so another thing that just kind of strikes me is how nice it is to see this that just progression. This I know Dr. Page has actually received many awards for many resources and so on, and is highly respected. And it's just a pleasure to see how the Pathway Award has kind of contributed this. The ADA's Pathway Award not only has it promoted and helped Dr. Page do her research, but look at it, we have now a wonderful new person, the future of neuroscience, the future of research in this area, just now emerging. So it's really incredibly gratifying to see that. So thank you so much for just your time and just inspiring us, because I think this is an incredibly inspiring story, and we look forward to really seeing great progress and all your successes in the future for both of you, Dr. Page and also to Charis.
Thank you so much for having us, and thank you for sharing the story with us about your journey. It's been really, really wonderful. I just was so excited to learn about it. So thanks again for sharing.
Absolutely. Thank you so much for letting me be a part of this and inviting me to be a part of your study all these years.
And thanks so much for the work you both do. This is so important, and this is just absolutely what we need moving forward in research and to help people, whether diabetes, neuroscience research. So much appreciated, and it's wonderful to see this. Thank you so much. Bye.
Bye-bye.